Hello Geometry class of 2011 and 2012. We are teaching chapter 8. I, Ara, will be teaching the first two lessons. Recall a over x equals y over b. The x and the y are the means. Now, if the x and the y are congruent and a and b are positive integers, then a over x equals x over b, making x the geometric mean. Now, in theorem 8.1, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles are similar to the original triangle and each other. This is because of the angle-angle postulate. These three angles are congruent, these two angles are congruent, but this angle is for the big triangle and the little triangle. Now on to the corollary 1. When the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. This means a over x equals x over b. This is because of the first theorem that the two triangles are similar to each other. Moving on to the corollary 2. When the altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean of the segment of the hypotenuse adjacent to that leg. This means in this triangle here, C over E equals E over A, as well as C over D equals D over B. This is because the larger triangle is similar to the smaller triangle. Now, keep in mind simplest form. This is when numbers are under the red sign. No perfect square factor other than 1 is under the red sign. No fraction is under the red sign. And no fraction has a red in its denominator. Okay, cameraman, do you understand this?
Yeah.
Okay, good. Now moving on to 8.2. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. A Greek named Pythagoras created this formula: a squared plus b squared equals c squared. This is because of the second corollary. Because c over a equals a over e, and c over b equals b over d, then a squared equals c over e, and b squared equals c over d. Now a squared plus b squared equals c, parentheses, e plus d, which equals to c squared, making it a squared plus b squared equals c squared.
Hello y'all, today I'm here and I'll be teaching chapter 8 lesson 3 and lesson 4. Let's begin with chapter 8 lesson 3. So theorem 8.3, if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. I'll explain it this way. So let's see triangle ABC here. Well, segments A, B, and C, and you know the Pythagorean theorem is a squared plus b squared equals c squared, right? However, in this proof, we don't know that this is a right triangle. It's just a triangle. But then if we copy these segments to a new triangle EFG and put a new segment here D, and this is a right triangle, then a squared plus b squared equals d squared. And according to this theorem, a squared plus b squared equals c squared. Therefore, c equals d. These two triangles are congruent. Angle B is a right angle, and ABC is a right triangle. Moving on. Theorem 8.4. Alright, listen up guys. So if c squared is less than a squared plus b squared, then measurement of Q is less than 90 degrees. Measurement of Q is this measurement right here, this angle. So if this C gets smaller, then Q compensates and also gets smaller, so it's an acute triangle. Okay, so theorem 8.5. So if c squared is greater than a squared plus b squared, then measurement Q is greater than 90. So let's put it this way, simple terms. So C, if it gets bigger, then Q compensates and also becomes bigger, so it becomes an obtuse triangle. Moving on to 8.4. Alright, so listen up. Theorem 8.6. In a 45, 45, 90 degree triangle, the hypotenuse is rad 2 times as long as the leg. So let's say that according to this proof, these two sides are A and this is C. Then a squared plus a squared equals c squared according to the Pythagorean theorem. 2a squared equals c squared, so a rad 2 equals c, so this is rad 2. Okay, moving on to theorem 8.7. In a 30, 60, 90 degree triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is rad 3 times as long as the shorter leg. Okay, so if you see here, these two triangles, this is a 30, 60, 90 degree triangle. Well, this is a 30, 60, 90 degree triangle. Alright, so first of all, this is A, B. So we're gonna draw another of the same triangle. So it's gonna be A. And because this is 30 degrees and this is also 30 degrees, this is gonna be 60 degrees. So it's gonna be an equilateral triangle. So this is 2A and this is also 2A. And according to the Pythagorean theorem, B squared plus A squared equals 4A squared, because we're squaring this. And therefore, B squared equals 3A squared. And if you square root these, it's gonna be B equals rad 3. So A rad 3. So therefore, this side is always this is rad 3, and this is 2. So to explain it further, just to put into simpler terms, in a 30, 60, 90 degree triangle, opposite of 30 is 1, opposite of 60 is rad 3, and the hypotenuse is 2. Thank you for listening.
My name is Vincent Chua. I'm going to do section 8.5 and section 8.6 of the chapter 8 right triangles. So there are 3 special equations you can use in right triangles. There are tangent of section 8.5, sine of section 8.6, and cosine of section 8.6. Tangent of angle A in triangle ABC is BC over AC. Tangent of a certain angle is opposite leg of the certain angle over adjacent leg of a certain angle. So for example, this one, tangent of angle A is BC over AC, like this. You can memorize it like that. And then sine of A equals BC and AC. BC over AB. Sine of a certain angle is the opposite leg of a certain angle over hypotenuse. Like this. And cosine of angle A is AC over AB. Cosine of certain angle is the adjacent leg of a certain angle over hypotenuse. For example, like this.
Hi, my name is Ethan, and today I'm going to teach you about section 8.7. So, in this diagram, there's this boat and this lighthouse that are looking along this line towards each other. And to find the angle of depression, we draw a horizontal line from the lighthouse. And so this degree X is how far they are looking down to see the boat. And from the boat, this horizontal line and this horizontal line, this angle X is how far the boat has to look up to see the lighthouse. And this is called the angle of elevation because it's looking up from the horizontal line. And this is called the angle of depression because it's looking down from the horizontal line.
Kids, I want you guys to enjoy the wilderness and the beauty of nature, but I also want to ask you guys what you have learned today.
Well, we learned SOHCAHTOA, like sine,
Cosine
And tangent.
And what else did you guys learn?
I wanna be the very best, the one that gets an A+. I think I'll get an A on a test. To go to Harvard is my goal. Geometry, gotta learn it all. It is my destiny. You teach me and I'll learn the theorems. Geometry.
Don't forget the postulates!
Geometry.